Greeting to everyone. My name is Ilmaz Hakim Zulkifli. Today I want to explain about DMA. So, what is DMA? DMA stands for Direct Memory Access. DMA is method of transferring data. DMA is a feature of computer system that allows certain hardware subsystem to access main system memory or RAM. DMA can make the cycle shorter as it speeds up the transfer of the memory. It can save processing time and it's more efficient to move data from the computer's memory to other device.
In older computers, four DMA channels were numbered 0, 1, 2, and 3. When the 16-bit industry standard architecture ISA expansion bus was introduced, channels 5, 6, and 7 were added. A computer system resource tools are used for communication between hardware and software. The four types of system resources are I/O addresses, memory addresses, interrupt request numbers, and direct memory access channels. Direct memory access channels are used to communicate data between the peripheral device and the system memory. All four system resources rely on certain lines on a bus.
Without a DMA, when the CPU is using program I/O, it is typically fully occupied for the entire duration of the read or write operation, so it will not available to perform other work. With a DMA, the CPU first initiates the transfer, then it does other operation while the transfer is in progress, and it finally receives an interrupt from the DMA controller when the operation is done. DMA also has some disadvantages, and that is DMA transfer requires a DMA controller to carry out the operation. Hence, it is more expensive system. Nevertheless, why don't we just sacrifice a little bit more money that could really help us to fasten up our work? So now you know what is a DMA, but let's go deeper into the process.
So, there are several conditions must be met for direct memory access to take place. The first condition is the I/O interface and memory must be connected. In some systems, both already connected by the same bus, so this condition is easily met. The second condition is the I/O module must be able to read and write to memory. It does so by stimulating the CPU's interface with memory. To be specific, the I/O module must be capable to read and write to memory data register and to load memory address register. The third condition is the conflict between the CPU and the I/O module must be avoided by any means. Memory can only be used by one device at a time. The last condition is interrupt required for completion. This is because the CPU is interrupted to handle the cleanup after the direct memory access transfer.
Okay, so let's see the workings of DMA controller. Okay, first we have the CPU, then we have DMA controller, then we have disk controller, and lastly we have memory. As you can see, it contains 4 blocks and are all connected by bus. There are 4 processes that take place in these 4 blocks, which are read data, request, transfer, and send acknowledgement. During read data, this controller read data from drive and store it in the internet buffer. In the request process, the DMA controller will request to the disk controller to transfer data to memory. Next, in the third process, the disk controller will send its data to the memory. In the last process, this controller sends an acknowledgement to the DMA controller to decrease the count. Now, the count will be checked. if it is equal to 0 or not. If it is not equal to 0, it will repeat steps 2, 3, and 4 again. When the count is equal to 0, it notifies the CPU that the transfer is done. So, in this way, DMA saves the cycle so that input, output, and memory can have a direct access without the involvement of CPU. Thus, DMA is important in the transfer process.